in this situation, but the math that you use actually would not always work, and probably never again on any other problem. So I want to go over them just so you understand it for if you see it on your written exams when you take those. So this was one of the ones that was tripping up a bunch of people. So the question said, a single lap sheet slice is to be used to repair a section damaged aluminum skin. A double row of 1/8 inch rivets is used. The minimum allowable overlap will be what? And again, if I draw side view, we've got, it's really hard to draw straight when you're doing like that. Two pieces overlapping, connected with 2 rows of rivets, so that's the side view. And we want to know the overlap distance. If we flip it up, it'll look something like that, and then this other piece of metal coming under, and I'll draw, what kind of line is that? Beautiful. And what is the one thing they do not specify, not very nice, about the rows of rivets? They are staggered. And a bunch of you that got it wrong, you drew it well. Like you remembered it was staggered, so you got that part. And I think pretty much everyone, you knew, that line's a bit off, that the edge distance should be what? 2. So you got, okay, from the center of those rivets, and from the center of those rivets to the edge, that distance should be 2D. So you got a good portion of it correct. I gave you credit for what you got correct. But then, the big question was, the space between rows, what in the world is that? So, what happened, if you want to look at previous lectures for the whole explanation, but because we're staggering them, we can bring them, the rows, closer, and if you work through the math, the absolute minimum, which is stated in the textbook, because AC 4313 just expects you to figure out all the math stuff. Absolute minimum for a staggered row of rivets is what? 2.5 of the diameter. 2.5D, and it is 1/8 inch rivet. So if you go 2, 4, 8.5, 6.5. That's why I don't do math in my head. 6.5 times 1/8, you'll end up with the correct answer. So mainly remembering, do you, new thought, do you think you would do this very often in the real world? Correct, you would not, because you would stay away from minimums. However, when it comes to prepware, getting ready for your written, just try to memorize this one, that when it says minimum, and talk about overlap, go with 2.5 diameter in between. So one of those things you just have to talk about it. Any questions? And the other one was this one, excuse me. The length of a rivet to be chosen when making a structural repair that involves joining 32 and 64 thousandths aluminum sheet. Drill number 30 drill is what? And I think, so most of you, I think everybody on this one, you knew that you needed to combine 32 thousandths and 64 thousandths to get your total thickness. So we're trying to figure out the length of a rivet. So you knew that. So that was very good. Again, gave you credit for work correct that you did. But from here, it got kind of messy. And people had really cool, creative ideas. But this is a tricky one because it doesn't specifically tell you the exact size of the rivet. But it gives you information that you can figure it out. So, that.
Wait, is that like the grip or?
Yes. Yep. The total thickness of the material. 32,064 together. But what rivet would you use if you are using a number 30 drill? A size 4. So a size 4, and what diameter are rivets measured in? 30 seconds. And that reduces to 1/8. So I think maybe some had different ideas on what number 30 drill could be. So just another thing to kind of memorize, that number 30 drill is for 1/8 inch rivets. When you're doing a riveting project, you're thinking opposite. Like, I have a 1/8 inch rivet. Oh, I need a number 30 drill. So this is kind of opposite of what you're used to. I think maybe that's why it's tripping people up. And then what do you do with that information? We got our total. So if we have our pieces of material, so we're going to rivet together. And we already got total thickness. How far do we want the rivet to extend through so we get a good shot head? 1.5 times rivet diameter, which in this case is 1/8. So take 1/8 times 1.5 plus total thickness. So this is a formula. I mean, you've been doing it, hopefully you're not just guessing. Been doing it over and over on your riveting project. But again, one to kind of keep in mind for your written exam. Length of rivet, total thickness or total grip, plus 1.5 times diameter. Any questions on that? Any other questions on the quiz? I am putting notes on your worksheets, and I'll be returning those hopefully today or tomorrow. So if you're seeing your grade change in Moodle, I put in Moodle a little note of either maybe I gave you credit because Moodle marked it wrong, but you showed me some good work, so I said work shown, or maybe I took a point or half off because you guessed the correct answer, but then not all your work was correct. So when you get your quizzes back, you'll see more of my train of thought. Yeah.
If you were to do it the way where you're using the thickest sheet, to find your diameter, I know they're telling you you're using a
Right.
drill.
Right.
You would have
So but you're still using a 30 drill, so you have to use a 1/8 rivet. You can't use
but
one.
technically, why would they use the 30 drill? Their rivet length would be
Yeah, so there you go. Who knows why? Yeah. And yeah, go with the number 30 drill rather than, but that's very good thought. In the real world again, either follow the structural repair manual, which may tell you that, or maybe have the upside, or, but you would do it correctly rather than that. day this week. We'll be having a lecture, not a crazy long one, short lecture, releasing a new lab that has to do with that lecture. But next week, we only have one new lab release next week, I think Tuesday, and then the rest of the time will just be lab time. So if you feel like you're feeling overwhelmed by the end of this week and there's a whole bunch of labs to release, don't. That's hard to, easy to say, hard to do. But you're going to have plenty of time to work on all of them. I'll be releasing them because some people will be finishing up, wanting more work to do. Maybe not more work to do, but being able to move ahead. And I want the labs to be available. And also, once you're done your riveting project, you don't have to do the following labs in any certain order. Like, I don't want everybody on the spar installing their high lock all at once. And I don't want everybody putting out circle path, which I'll talk about today, on Beverly all at once. So I want people to kind of be doing different labs at different times. So that's why I'm releasing them kind of quickly, and then next week you'll have plenty of time to work on them all. That being said, if you do get all your labs completed and we still have a couple days of class time, there is an optional spark plug tray that you can make. So if that's something you want to do, that will be available if you get all the labs. Okay, stress skin repair. We'll be reviewing what stressed skin is, types of repair you can do on it, and how to prepare the repair and then install your patch. bad area and then formed a piece to match it, could you weld it? And exactly what Brian said, you can make a perfect fit. You could fill the hole completely, but changes the metallic structure, which could induce stress. So that's why welding's not used. What if you, again, cleaned it up, put in a new nice piece of metal? Why or why not would you use bolts? And let's say we figured out the spacing somehow. We're not adding a ton of weight, because normally I would think, ooh, bolts so much, you're adding weight. But let's say we figured out spacing wouldn't be that much more weight than rivets. Why would you, good or bad option, use nuts and bolts?
They are more likely to loosen up than go against.
Precisely. They have some, even when they're torqued down, there's still very slight motion, and the nut can back off. So that is why rivets are king. Woo! Yay. So rivets are best. They don't, if the temperature changes, like with welding, when you install them, they completely fill up the hole, don't budge unless external forces are applied. So the idea, as we go through all of this, is when you do a repair, you want to restore the damaged parts to the original condition. And you're going to have to determine what quality is needed and start to think about big picture. Is strength important? Does it need to be leak-proof? Is it on floats? Does it need to be streamlined? Is it like on the leading edge of a wing? What about accessibility? Can you get to the backside, or do you need to see if line rivets are allowed? What is the function of it, and what requirements are listed in the manual? So gathering all your information. And I would like you to go to AC 4313, those paragraphs. And if I could get 2 volunteers to read that. Stop on 11. So if someone could read page 4-11, paragraph 4-50, Bravo and Charlie. Thank you.
Any repair made on an aircraft structure must allow all of the stresses to enter, sustain these stresses, and then allow them to return to the structure. The repair must be equal to the original structure, but not stronger or stiffer, which will cause stress concentrations or alter the resonant frequency of the structure. All metal aircraft are made of very thin sheet metal, and it is possible to restore the strength of the skin without restoring its rigidity. All repairs should be made using the same type and thickness of material that was used in the original structure. If the original skin had corrugations or flanges for rigidity, these must be preserved and strengthened. If a flange or corrugation is dented or cracked, the material loses much of its rigidity, and it must be repaired in such a way that will restore its rigidity, stiffness, and strength.
Thank you. So as we go through the rest of the lecture, this is where I'm getting a lot of this information and then expanding on it. But paragraph B, the repair must be equal to the original structure but not stronger, is key. Well, you're always coming back to it. Page 4-26. Paragraph far above 1843.13. So must be equal to, but not stronger or stiffer than the original structure. Why could it not be stronger or stiffer?
Transfer stress to another place.
Excellent. We'll get stress concentration, cracks, and then you're back with a worse problem than you probably started out with. All repairs should be made using the same type and thickness of material that was on the original structure. However, you may not always need to recover original tensile strength of the skin. So your rivet pattern might be a little different. Always refer to the maintenance manual, because to put a patch in, you might need more rivets than what obviously was originally there. Maintenance manual will direct you for that. So here is what it looks like if you have a nice piece of sheet metal and pow, somebody shot you. Oh no. And normally all these lines of stress as that structure is flexing and bending and taking on all kinds of stress. Lines of stress would just run straight across. But if metal is missing, there's a crack or a hole, now the stress has to go somewhere else, so it's going to go up this way. Everything is now taking a turn, and the cracks will develop somewhere along where that stress is being deflected. Kind of like a rock in a stream. The stream is flowing, but oops, now it has to go around something. So what we want to do in a repair is give that stress a nice, happy place to flow, and we want to, here's our hole, bridge the gap so the stress can flow across it instead of jerking out around it. So now the stress is flowing up the rivet, across the plate, and down the rivet. Now the stress is happy, you're happy, no cracks, hopefully. So remembering the load is transferred through the rivets. The rivets are a critical portion of that, and across the plate that is your patch. So a patch may be used for minor damage to outside skin. Again, it must be the same material, and how big your patch is depends on the size of the hole you're going to repair, and also on the number of rivets required. So you can see when you go to the lab portion, and I'll have the figures up here. But it'll say if you have a 1-inch hole, then you need a whatever inch patch with certain number of rivets. As your hole gets larger, you need more rivets. So it will tell you that. There are two basic types of patches, a lap or scab patch. So depending where you go, what manual you'll look at, they'll use either term. But it means if you have your original piece of metal, it's just overlapping, so that's where the lap comes. Or if you get a boo-boo and then you get a scab on your skin, it's just kind of resting on top. That's where that term comes from. And then the other type is a filler plug or flush patch. And I have some images of them, but if you have an area of skin that needs to be aerodynamic and have smooth airflow, you're going to make your patch flush with the existing skin. And we'll look at what that looks like. So first of all, when you have a hole, there's poor guy that has to patch up all the little holes. You want to clean up the hole to relieve any circumference. The size of the drill bit will be listed in the maintenance manual for that aircraft. AC 4313 on page 4-40 gives a general rule of thumb. And 4-40, top left-hand side says drill small holes 3/32 inch or 1/8 inch at the extreme ends of the cracks to minimize the possibility of their spreading further. So it'll depend. Yeah.
To remove the area with the cracks in it?
So it depends where they're at. And again, maintenance manual would tell you. But if it's not in a supercritical area, you are allowed so many cracks, certain distance. So if it, because like stop drilling, drill it a temporary repair. So if you stop drill it, like, I'll come back, patch it up later. And then eventually it will start cracking out again. And sometimes it'll allow like 2 to 3 times of stop drilling, or it'll give a length, or if it starts cracking out this way, like maybe let's say 4 cracks. But it'll be in the manual and it'll give you limitations on at what point you need to patch it. So here are the 2 types of patches I was talking about. So the lap patch or scab patch, here is our original skin, and it didn't get a hole punched through it, but it got booped, and now you have a big dent. And the patch just lays right over top with rivets around the edges. The flush patch or filler patch is a little more involved. So we have a flush patch that goes right in between the areas that were cleaned out. So here's our hole, here's our original skin. So this has to be the exact same thickness as original skin and fit right snug down in there. So be real precise with your measurements. Yes?
With the lap patch, wouldn't the dent cause stress pulling the surrounding metal in?
So ideally, again, depend on the manufacturer's manual, but it may have you clean that out, and yes, I would think there would be stress on rivets on whatever edges. So it's weird they give that example, because normally you're just repairing a puncture or a hole. Because if this happened, like that's a pretty serious dent, you might replace that whole panel, because if it's yanking all the rivets on the edges.
There's no crack just to like try and just get the dent out of it?
Sometimes, yes, sometimes that is allowed.
You're saying,
Parker.
for the flush patch, how would you get the doubler underneath it?
We'll go over it. Yes.
I just want to ask for clarification with what he asked, like if it's a dent, even if you have the patch, it'll still, stress will still be transferred through the dent and potentially,
Right.
because that what you were saying, like it's kind of, you have to look at the manufacturer, but that would probably
Right.
happen even if it's a dent. If you have a dent and you even have a patch, it'll still,
I would
be as
think,
simple as just all the stress is now transferred through the rivets.
right, like there'd be a little bit running through here still, but you're really helping it out, taking it off of it. Parker. Oh, you did ask me. In my mind, I was, but I wanted to address it, because I said we'll talk about it later. Yes, so, you have to have access to the backside. It can't be, maybe you might have to remove some other panels depending where it's at. But, so you have this patch that goes in between where the damage is. Then you obviously need something to back it up and reinforce underneath the skin. So that's called a doubler. You're kind of doubling it up. That goes underneath the skin. So what happened, and you're going to be doing this, talk about this tomorrow, the doubler gets riveted to the skin, the skin to hold it in place, and then also riveted to the flush patch. And you'll be doing one of these.
Can you do
later.
doublers and flush patch on the wing?
Yeah, yeah. Again, it depends where and on the manufacturer, but yes, possibility. Some of it be a challenge to get to. So a lot of these, depending where it's at, might be easier to just replace the whole panel, depending how big the panel is. Any other questions on there? So you can have different shapes of patches. Circle is preferred because that spreads the stress most evenly. However, if you have like a long, narrow damage, it may direct you to do a rectangular patch. However, always, 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 you must round the corners. Otherwise, if you have a sharp corner, now you're going to have 4 new areas of stress, 4 new cracks pretty soon, and you just made your damage worse than it was before you tried to repair it. So always round the corners. What you are going to be doing is something like this. So here we see the difference between AC 4313, which you can turn to page 4-32, is where that is from. So they say, and this would be a greater version, sorry.
No, you're okay.
This right here. Yeah.
So on the last slide,
Yes.
I don't know how important it is, but like, the grain of your metal is gonna be going one way. How important is it that the grain of the metal and the patch go the same direction as the original steel?
That,
I don't know if there's
I'm not-
stress issues there.
right, that's a good thought. I'm not coming across any data that says anything about that. Because it will still carry the stress either way. But a very good thought. So AC 4313, if you want to do a round patch, like this one, red letter K if you find it in your books, and it says you need to use 8 5/32" rivets. So who would like to do I should have hidden this, but let's say this is a critical area and you have to do a 337 form. Who wants to do a sketch and a repair based on that? Me neither. So thankfully, manufacturers give you way better data, way better figures, unless you get into really old manuals. But here, it says, patch and doubler if you need it, 2024 Q4, same gauge as skin. This is a certain area of the aircraft. And MS 2470 AD4 rivets for this one down here. 8 rivets required. If you are doing a 1-inch diameter hole, your patch has to be 2.5 inches in diameter. And between centers of rivets is 1.75 and 45 degrees apart. Ton of information. Super helpful. Yeah, I'll talk about that now. So do you remember, way long ago in drawing class, what the secret is to easily lay out your rivets for this 1-inch damage, 2.5-inch circle patch?
Fold your paper in half and half and half.
Exactly. Take a piece of paper, cut it to the correct size, fold it, fold it, fold it again, crease it nice and hard, open it up, edges, make it secure. Center punch right through the paper onto your metal, and then draw your rivet hole. Beautiful. Dwayne taught us that, so if you see him around, you can thank him. Any questions on that? Yes.
The bottom, what is the filler attached?
It does not specify here. On the lab, we're gonna give you some more information. That'll be tomorrow. We're gonna talk about, I think, sealing patches. So it may somewhere else tell you if you should use a little piece of metal for that, or if it's somewhere that you can use something else. So it kind of depends where on their cup it is, what you would use for that. Ew. There goes question. Very tricky. You know it's coming. So.
Did you put the filler on the doubler before typically, or do you try to get the doubler in first and then put in the filler?
It depends what the filler is. So, for the patches, I'm giving you information for tomorrow, you'll be using a piece of metal cut out as a little coin. So, I'll kind of let it up to you, what you think might be easiest. But, yeah, I'll leave it at that. Use your creativity and ingenuity. Very good thought. Yeah.
Is that a similar patch to what we would be expected to make for our practices?
It is. And that's why we're having to do this. Because it's actually become fairly common the last couple of years that people do a chuckle patch.
But if we do good enough on the beginning of our practice, we want to finish.
Hey, what if you get this at the beginning? Spits out random stuff. Yeah, no. Any other questions? All right then. Oh, who will be the first one? And Sam. When repairing a small hole on a metal stressed skin, major consideration in the design of the patch should be shear strength of riveted joint, or to use rivet spacing similar to a seam in the skin, or that the bond between the patch and the skin is sufficient to prevent a similar metal corrosion.
Bravo.
He said bravo? Uh-oh, they're shaking heads. How many say, let's start from the bottom. Anybody say Charlie? Good, because why would that not be, why would you say no?
Using the same material.
Using the same material, there should be, if you have dissimilar metal, you've done something very, very wrong. How many say bravo? Good for you, you got it, Fred. How many say alpha? Whoa. So, why not bravo?
Because oftentimes it's different.
Look at the maintenance manual, oftentimes it's different. Yes. So, like, this is actually a really good example. This patch, let's say we went to the seam next to it. Well, the seam doesn't have a circular rivet. So, that doesn't work out. Also, now, if you are replacing a panel, 100% you want to match the seam that was there before. But this one says, use rivet spacing similar to a seam. So, if I'm working on the wing and I go back to the tail and, well, that's a cool seam, I'm going to use that one, that makes it too broad. But shear strength of the riveted joint is a major consideration. Next one. Oven. Parts fabricated from Alclad 2024 T3 aluminum sheet stock must a good thing if you can, but, good. So, yeah, Charlie's correct. And John. When a piece of aluminum alloy is to be bent using a minimum radius for the type and thickness of material, the piece should be bent slowly to eliminate cracking. The layout should be made so that the bend will be 90 degrees to the grain of the sheet. Less pressure than usual should be applied with a movable or upper clamping bar. He said B. Any disagreement? Very good. Correct answer. The other two are quite unusual. Bend it slowly. Anyway, I'll move on. So, the flat layout or blank length of a piece of metal from which a simple L-shaped bracket, 3 inches by 1 inch, is to be bent depends upon the radius of the desired bend. The bracket, which will require the greatest amount of material, is one which has a bend radius of 1/8, 1/2, or 1/4.
One that cuts the least amount of corner off, so 1/8.
Excellent, an excellent explanation. So, 1/8 or the smallest radius will need the greatest amount of material. And that, whenever I had my little paper up there, it showed if you have a 3.
Yeah.
That's funny.
Yep.
Yeah.
But if 3D is the minimum between rivets in the same route,
Yes.
then it would probably be allowable.
Yeah.
So that's fine. And then another question, this is on the bottom of a hair cube. So there's supposed to be like those 3/16 hole with like a clamshell cover over it. So I installed 2 of those,
Yeah.
but one was supposed to go right here, but it's just got a wonky hole, like they didn't even drill like a round
Yes.
hole. And then it's got like a gasket on it,
Huh.
and then like aluminum or stainless piece with a stud on it, and then so it goes through that hole, and then there's a wing nut on top.
Okay, yeah.
So I don't know. I mean, there's supposed to be a drain there, but I don't know if somebody saw a boat drain there. But
Oh, that is very interesting.
I don't know, would that be something you would, rivet in a patch and install like the proper drain, or apply it,
To do it
or
correct, yeah.
I don't
Yeah. On that, like, something like that, I go to Steve or somebody that's done it for a million years. But, yeah, to make it truly airworthy. That's very interesting. Whew.
There's actually, I should have taken a picture of the bottom of it, but I don't know. There was like one over by the fuel tank too, and one over here.
Hmm.
But I never saw like the outside of this because it's like inside the wing.
Yeah.
I don't know.
That's
if
very
it's
scary.
approved or not.
Right. Yeah.
This, I was trying to interrupt real quick.
Oh, yeah.
There's a question.
Oh, yeah.
If I'm thinking about this correctly, do you subtract the stock loss from the bend review?
Yeah.
You basically, your loss is basically here. Right? This is your bend, like, cause you're trying to get your setback essentially, correct?
So 5 feet.
You're going home.
I'm beating you.
You just have to sit out there.
No.
Sure.
Oh.
Not gonna keep you warm.
Throw a lot there, come on, go.
Alright, I think everybody's got 45, time to start again. And the break did several of your brains good. You came to me with the correct answer. The rest of you. Going back to the question when I released you on break. What is the neutral axis?
Imaginary line.
Imaginary line. So I got that. Imaginary line that unicorns run on?
That's 0.445 from the inside.
Whoa. 0.445 inches from the inside of the vent. So if you see this, oh, amazing artwork that's no longer there. So if you have metal that, like this right here, we'll pretend that's a radius that bends. The thickness of the material, about approximately halfway, is the neutral axis. So, going back to the question, how you find it, Parker, what's the answer? It is Bravo. Found by adding approximately 1/2 of the stock thickness to the bend radius. Any questions on that one? And Sydney. Unless otherwise specified, the radius of a bend is the inside radius of the metal being formed, inside radius plus 1/2 the thickness of the metal being formed, radius of the neutral axis plus 1/2 of the thickness of the metal being formed. A. And any disagreement? That or not, that is correct. And Tim. I'm making him nervous. Too much fun. The sharpest bend that can be placed in a piece of metal without critically weakening the part of bend allowance, minimum radius, or maximum radius.
C.
C, maximum radius. Ooh, disagreement. I think Corbett was first. It was very close. Bravo. How many say, anybody say alpha? Like, so, the sharpest bend is the minimum bend, or the tightest that you can bend it to. The larger the radius becomes maximized the bend. So, minimum for teeny tiniest. David, the most important factors needed to make a flat pattern layout are what? So I had told you you don't need to memorize the formula. However, having a good understanding of it is very helpful. So, important factors for flat pattern: radius, thickness, and mold line, or radius, thickness, and degree of bend, or length of the leg or flat section.
B.
B. How many agree? much it's being bent, so bend radius. So is it a really tight curve or a really big, gentle curve bend radius? Sorry. Got it. When bending metal, the material on the outside of the curve stretches while the material on the inside of the curve compresses. The part of the material which is not affected finding the information, it's probably because you're looking in the wrong place. Make sure for that question you are referring to the reference it gives you. And then, if I go back here, part 2, stress skin repair, is a paper copy I'm going to hand out. But while we are here, I want to show you a handy reference. Right here, Cessna Structural Repair Manual is in Moodle under course resources. Hold that thought, I'm going to hand these out and show you where this will come in handy. Somewhere's 2 extra copies.
We have one.
Thank you. You're not forgotten. Okay, so I'm going to go over this now. Again, if you don't get to it even this week, it's okay. So, go to page 2 and do the questions on Moodle first, because that'll kind of start guiding you down the right path. But what you're going to do is follow the directions. So make sure under step 1 it says material prep. Use 20 or 25,000, either one. Used stuff. So you are not taking brand new shiny metal. You are getting used stuff. When you're ready to do that, see either me or Anna will show you what to use for that. Because this is mimicking that you are working on a plane that's been out flying around, so it's not going to be the cleanest thing ever. And you're going to make a 6x6 plate. It gives you exact dimensions, tolerances, and that is going to represent the portion of aircraft that you are going to repair. Once you get the 6x6 plate done and is correct, you need to have that signed off before you move on. So, instructor's initials that that's completed. Then, you're going to do a very sad thing. You have this beautiful, perfect 6x6. Drill a hole right in the center. Boom. But, make sure it is less than 1 inch, or you're going to probably cry. No. You're going to have a very bad day. So, less than 1 inch diameter hole, that is the damaged area. Now, unless you want to give yourself a really hard time and come back next year for sheet metal, you will use a drill bit. You won't create damage in some other unscrupulous manner. We will make you pay. So you'll do the hole in the center. Then it tells you what aircraft, 1983, so then you know what manual to use. Make sure you are using that manual. However, I will show you what it looks like. So, this is the manual that you're going to use for the lab. It's not great quality. However, it shows that the patch is to be on top and has the same rivet spacing, size, everything as the other one. So I want your patch like this, since it is giving you the scenario of this aircraft on top with universal head rivets. But it might help you if you compare somewhat to the Cessna structural repair manual that's in Moodle, because it is a more clear drawing. So if you want, need help, like my eyeballs need help to get this circle dimensions and everything. They are the same as the other one. The only difference is this shows a patch underneath. So you'll see there's differences between years, between models. The 414 is actually very similar to this older manual. Kind of depends. Doesn't really make a big difference. But for my lab, I want it to be on top, like just like the manual shows you. And then you need to do a drawing so you can kind of copy off of this. And I need to sign off on your drawing with the next instructor initials. And then, after you get your drawing signed off, yes,
Are you allowed to use a drawing?
absolutely, yes. So from drawing class, you did something like this. If it matches what this manual says, you 100% can use it. So that is the trick. If it matches, I think we did. I think we did. Still hang on to that drawing because this is just the first. There'll be more repairs coming up. But yeah, if you can definitely reference it, use it as a, I'll say that. And then after you get the 6x6 signed off, drawing signed off, then step 3, perform and stress skin repair in accordance with the manual. Once you have it complete, I will sign it off on the last initials. Then you need to save it. I will make sure you get a grade from me, which I'll put in my little grade book. But make sure I grade it because tomorrow we're going to talk about what you're going to do next with that. But you must have that project to do the next step. And then on the back is a logbook entry for work performed. Any questions on that? Also, with the special fasteners lab, the high lock bolts and the cam lock, I need you to return those to me once you're finished. So high locks you'll install, uninstall, cam locks on that little plate, install, remove, and then I need all that hardware back because it's very expensive and we do save it year to year as cable. Any questions? All right, rest of the time is lab time.